Okay, so the first part of the video I want to talk about how we store and access the point cloud data. So we use this cloud-based system called Cintoo. The reason being is, first of all, it makes the data really accessible. So we can, just by coming up within the project, go into the members section, add in my team, anyone from the client side, and any external engineers that are part of the project, just by adding their email address in, and straight away they get access to what we're seeing today. Now, the second reason that we like using it is, first of all, it's a lightweight system. So first of all, they're obviously storing all the point cloud data. I believe they actually mesh the data, which actually makes it a lot smaller in size, so it helps with bandwidth. And I'm just viewing it from a browser, so I'm not actually required to have any kind of powerful machines to be able to access this. And then third of all, it helps us with collaboration. So just by going over here to the annotation section, I can actually add annotations and write my queries in on this. And by doing that, I can actually put a question in here. So what valve is this? I can tag my team on it, and then it becomes that kind of central hub for filling in issues and queries about certain stuff. So the other parts that I wanted to go through was, first of all, we're able to not only view the point cloud data, which is what you're looking at here, and we're able to obviously pan and zoom about within the point cloud data really quickly and really easily, but also able to view the panoramic images, which is what you're looking at here. Now, the reason why the background is blurred out is because this is client data, and I just wanted to try and keep it confidential. Now, within this, we can actually change a couple of aspects. So we can actually change it so that we're actually changing the color of the data. So here we're actually looking at a height map, and straight away you can see this actually makes it so much clearer to read. We can jump about into the different images, and this color coding not only works inside the panoramic images, but also works with looking at the point cloud data when you're panning and zooming about. Change it back to RGB. Now, there's a handful of other tools within this system, including the ability to crop data out. I find that cropping the ground out really helps, because certainly when you're trying to trace small galvanized lines and you've got a grey base, it just can sometimes make it really difficult. And it just helps. Certainly as well with pipe racks, where you've got multiple racks of pipe work, you can just crop out, just look at the first rack and then move the crop tool up and look at the second one and just focus on what you need to focus on. So that really helps for us. And you've got the ability to add measurements as well. So this is the system that we use. Oh, one other point is that we've got the ability to upload 3D models as well, which is really handy. Again, just helps with that premise of trying to store all your data into the same location. And it just means that it first of all allows us to use it to quality control, check the models, but also, like I said, helps with the fact that all that data is in the same place. And I believe you can still see the model even inside the panoramic images. So if you changed it to, I don't know, X-ray mode or something like that, or the height map, you can still see the model. So that's just a brief introduction about Cintoo and how we actually access the data. The next part will be actually talking about Plant 3D and how we're actually building the P&IDs. Okay, so the next section I wanted to walk through and just give a brief introduction about is the Autodesk Plant 3D system. So this is actually an Autodesk toolset which actually comes with the AutoCAD subscription, so it's not any kind of external applications, and the system comes with both the P&ID and the Plant 3D, but obviously we're talking about the P&IDs today. So the reason that we at Neonex Digital use the Plant 3D system, certainly for building P&IDs, is because first of all it's a lot faster to initially build the P&IDs, and it also helps with maintaining the P&IDs afterwards, i.e. keeping them up to date. Now, when we first take on a project, we set up Plant 3D around the client standards or produce the standards for them. So this includes building the symbology, asset nomenclatures, all your borders and templates, including all your fonts and layers. And the reason that goes into the system like this is because it allows for the drafting or the P&ID consistency. And this was really prevalent for us for a project that we undertook, where I was part of a project which required something like 650 P&IDs to be produced in 10 months, and we had over 40 people working on the P&IDs at one point. Now, some of the other benefits of a system like this includes the fact that whilst you are drafting the P&IDs, you're actually automatically building data. You're automatically updating a database with information about all the assets that you put in. So, for instance, it includes this parent-child relationship where when you're adding a valve to a line, that valve automatically understands that its parent is the line, and if that line is attached to a piece of equipment, again that line understands its parent is the equipment. Now, in terms of the data, this is quite a big point at the moment because everyone's talking about digital twinning. A lot of companies now are using or implementing large asset or maintenance management programs, and before you can actually start building those sort of programs or implementing those programs, you need to have the asset information in there. So being able to export all your asset lists from the P&IDs as an Excel format and being able to import that straight into your asset system is a huge time saving, and it helps with the whole validation process. So that's just a brief introduction. One other point to bring up as well is that the P&IDs that we produce inside this system aren't locked inside this system. So though we produce all our P&IDs in the Smart P&ID system, they're not necessarily locked to it. So if we've got a client that only uses AutoCAD LT, we can export the P&IDs out once they're finished and supply those DWG formats so they're usable within the AutoCAD LT application. So that's just a brief introduction about Plant 3D. I'm going to move on now to actually producing the P&ID. Okay, so let's have a look at actually creating the P&ID. So this is obviously the data on the left that we were talking about earlier. So we're going to have a look at trying to create this P&ID in a geographical kind of state. And if you're unsure what that kind of means, I've done a whole kind of blog article about laying out P&IDs. So I recommend going to my website, nearnextdigital.com, and looking at the blog page where it talks about pretty much everything about P&IDs. So on the left here, we've got our Autodesk Plant 3D system. We've created, we've got this project, and in here we've created this single P&ID, which is automatically brought in the bounding box and the border in our layout space. So we're going to come over here to our tool palette, where we're going to pull off all the kind of smart blocks and bring them straight into our P&ID. And all this is all really customizable. So just put this pump in. It's asked me to put a pump number in, so it's going to give it 1001. And I'm just going to mirror it. And we're also going to add that equipment tag in, like so. So up here to align, so we get multiple line types for this particular project. So this is our primary line type. So we're going to use that for the main process lines, and then these smaller lines, which are kind of classed as utilities, we're going to draft them in a secondary line type, and we can have a look at how that impacts the data later on. So snap into the grid to the pump. Now if I select that line now, it's going to tell us that we're going to pump 1001. So we're already creating data here. Add that line in. So we're looking at this line here first. I'm going to go over to my valves. We've got a gate valve over here. I'm going to place that in. Now, because it's working off a parent-child relationship, which what you spoke about earlier, what's happened now? Now I've added that in. It's understood that it's come from an 8-inch line with a piping spec of 1, which for this project means it's carbon steel, 150 pound, which means that when this valve's gone in, it's automatically detected that it's an 8-inch valve. So if we came around here and actually changed it now to a 6-inch line, we can straight away see that valve is automatically taking that information. Now that we can see as well that this pump is flanged, so I'm just going to put this flange in. A bit more, like so. Okay, so off the top here we've got the outlet of this. Try to jump it out a bit. This outlet that comes off the top here. So add that in. Lines, secondary. Snap onto that. Bring it up here, and we can move all these about later. So it's alright just to kind of over exaggerate everything for now. And then we've also got. We'll stick to actually the process lines first. Got over here we've got a check valve or a non-return valve. Now you'll also notice that with non-return valves, when we add this in, it'll actually follow, it'll understand where the flow direction is going. So we've added that in, it's automatically flipped it. I'm also going to say that it's flanged, so I can right click, set in connections to flanged, and then alongside it we've got another gate valve. So again, we can add this in. I'm going to put a bit of space in, you'll see why in a minute. Select it, right click, select it, right click, set in connections to flanged. Now you'll also notice that when we add these components in there, it's automatically breaking the line. So you're not seeing the lines going through it. If I turn the grid off, it'll be a bit more prevalent. Now the beauty of that, with the standard systems, you'd have to go through and break all these lines all the time. And the other beauty is that if I select the line, you can see that even though it's broken underneath, it still understands that it's a group. Now the reason I put a gap in here is because there's actually a ball valve underneath there. So we're gonna, is that ball valve? Yeah. Come over here, so I'm going to take a different line type now. I'm going to class this as a secondary line type. It's all kind of under preference, to be honest. New S line group. Now the reason I said this is a new S line group is that when I come to select the line, it'll be classed as a totally separate line because it's teed off, so it needs its own separate line number. Add the ball valve in, automatically annotates it with the line number nomenclature. Set in connections to flanged. There we go. So we've also got this line that comes off here, which I believe is actually a globe valve. So what we can do, just words. I'm going to class that as another secondary line. So I'm going to add that in. So we're going to click new line, bring it up out of the way. Now this is a blow point, so it's actually blowing into the line. So I'll select it, we can go right click, reverse the flow. So now we're going back into it. Now I want to add the globe valve here, and then we'll do is bring this down and bring the non-return valve in. So both of these are flanged, so we can set both setting connections flanged, like so. And then right next to it, can you see there's also a threaded ball valve next to it as well. Add that in. Now this time we're not going to set the end connection, we're just going to keep it like that. So we've also got this bypass line that comes in afterwards. I'll class that as our primary line type. Select, new line group, bring it down here, like so. Bring this down, make sure we snap onto that. Okay, now the only other point we've got, I've got two, we've got another drain over here. So again, one of the beauties is that we can actually, like normal AutoCAD, pick it up, bring it over. I'm actually going to change that. I believe it's a gate valve, so if we go into the photo we can get a bit more clarity on that. No, I think that's going to be a globe, so we're going to select that as a globe. Let's go around and see if we've got a better. So there's our ball valve that we just put in. Here's a bypass with a gate valve on it. So I'm going to add that in there. Try and line it up with this one just for a bit of consistency. Got our valve in there. Now this line kind of comes around the corner here. I'm going to go back into my 3D navigation. And we've got a gate valve which has been cropped out a little bit, but I know it's a gate valve. Have an auto snap, like so. Gate valve in up here. So now I also want to add in this drain point or vent I've got here. So lines, class it as a secondary line again. Click, new line group. So enough space to be able to put that valve, and we come along and down. Okay, and then we can come around here and add that as a ball valve. So that's flanged. Okay, so how are we doing? So the only thing I'm going to add for this is that this line actually drains to the floor. So just add in a basic bit of text. So again, we're able to use basic AutoCAD functionality as well whilst using this system. It's not all completely new. And I'm also going to use the stretch command just to bring this over so it's not so far apart like that. Okay, so the only bits we need to add in now are all these smaller lines. So we added in this ball valve up here. I'm going to bring the line up, so I'm just clicking on the node, bringing it up, F8 to snap, well, auto snap, and we've got over here, let's have a look at the picture for a bit of clarity. We've got a ball valve, we've got a non-return valve, we've got another non-return valve here and a ball valve here. And go add the ball valve in, add the non-return valve in. Now this, the only issue that we have here is that this line is showing it's all going straight down. So what we're going to do is actually break it. So what we can do is come over here, break the line here, select it, edit S-line group, and we're going to remove this line. So it's now classed as a separate line. So we can now reverse the flow on that. And then we can bring this next line. It's on the other side of the process line, so I need a bit more space. So I'm just going to move this over just a tad. Lines continue with the secondary line group. A new line like so. valves. Ball, put the NIV in first. Space to put the ball in. Doesn't need to be set to flange because they're obviously not flanged. And then still need a bit more space. What we're going to do is that line drops down here and goes across and also comes back. So what we're going to do, take our line group, bring it down. Now I like to pay attention to here. So if I add this line in, can you see that it automatically breaks that line group? And that's part of the standard. Now depending on how it's all set up, depends on the lines, it will depend on how it breaks. So because this is classed as a secondary line group, the primary line group, i.e. these process lines, take precedent. So it's a secondary line that will break. Comes around here, comes along and ends up on the other side of this line. So what we're going to do, drop them down, drop them across, drop them down. Again, automatically break the line, but if we select the line, you can see that it's automatically connected. So we can now go add our off-page connectors in, automatically understand the flow directions, like so. Now one of the other beauties of these off-page connectors is that you can actually give them descriptions. Now the descriptions aren't against the off-page connector, but they're against the line themselves. So if I class it, put in here airline, for instance, that off-page connector is automatically picked up in it because it understands its parent has that description, and the same up the top here. So again, for this we can go give it P1001 delivery line. P1001 suction line, like so. So we could go into a lot more detail. As you can see, when I hover over these lines, you can see that they've all got their own individual groups. And if they were individuals, we can break them up. We can also come along here, give them their labels, like so. Annotate it. We can just say 6-inch. This has all been customized for our particular client. This is a bypass line which we don't have, so we'll class it as part of the delivery line. One, we can say it's ethanol bypass line. If you want to give it a description, parent asset P1001 assign. Automatically put that information across like so, and because it's part of the parent of this particular asset, it's automatically put that parent asset number across. Now the beauty is, if we go into the data manager now, we can first of all go into our hand valves. There's all our hand valves. Now some of them haven't been given line sizes yet, but you can see the ones that have been. It's got a parent asset there, it's line number, and we can even select these, which will automatically take us to the valve in question. We've got all our line numbers, so there's the one we've just given a line number to. 6-inch, nominal spec, its tag, its parent asset code, and any kind of line descriptions we've got. And again, like I said earlier, that's all just completely exportable to Excel. So you've got all that information that you could not only import into your asset management system, but you could also update it with information and re-import it back into the P&ID and update the P&ID in like a batch type process. Going to our latest base, there's our P&ID. So if you've got any questions, I'd love to hear your thoughts about certain aspects of what I've done today. If you're interested about learning more about it, or you feel like I missed something off, then feel free to drop me a message. Please take the time to go have a look at the website. So this is our website, Next Digital. We've got a lot in the blog section about P&IDs, if that's what you're interested in. We've got case studies about how we've used that data in the past. Yeah, I look forward to hearing from you all. Thanks for your time. Bye.